When talking about Kubernetes, getting to the subject of networking can often be tricky. On top of that, we start discussing service meshes, the best choices to make out there, what you need to be thinking about when approaching this topic. Can sometimes even be scary for practitioners. So we got a chance to speak to William Morgan, who's the CEO of Buoyant. Buoyant are the creators of Linkerd, very active in the service mesh space, something he's been working on for quite a long time. Now, if we're talking about this, we're going to end up talking, of course, about eBPF, sidecar, and also sidecarless models, talking about the cost and complexity regarding those particular choices, the data plane and control plane having different responsibilities and distinct roles inside of a service mesh. Of course, also speak about ambient mesh, standards such as the gateway API. William really has something to say and a lot to say about all of these. I'm sure we have enough to have a second conversation. This episode is sponsored by Learn K8s. Learn K8s is an organization that provides training so that Kubernetes practitioners can level up in their careers. The trainings are given both in person as well as online. They are 60% hands-on practical and 40% theoretical. If done, you have access to all the materials for the rest of your life so that you can continue to dig into those topics and improve your Kubernetes skills. For more info, check out learnk8s.io. All right, William, you got a brand new Kubernetes cluster. What 3 tools are you going to be installing first?
Well, first I would install Linkerd, of course, the best tool out there for any Kubernetes cluster, a necessity, I would say. After that, I'm kind of, uh, I'm a little biased in that really the things I'm most exposed to are the things that people use alongside Linkerd. So it'd probably be something like Argo and something like Cert Manager. Very boring, maybe, but that's I think with those 3 projects, you got yourself a pretty good setup.
We definitely hear, Cert Manager comes up a lot. Argo's mentioned a fair amount as well, talking about GitOps. Why not Flux?
Oh, actually, Flex would be totally fine. I'm agnostic between those 2. So yeah,
Okay, but
either
just
one would
something
be
from the
fine.
GitOps space. Okay, all right.
Yeah, that's right. Especially for things like progressive delivery, I think that's a really powerful tool when combined with Linkerd. If you want to do really safe rollouts and new code. So I like that stuff.
Okay. Um, you are a CEO. So who do you work for? What do you do? Tell me more about that.
Yeah, I've got the worst boss in the world myself. Taskmaster, uncaring. Just horrible, miserable person. Um, So yeah, I think the role of CEO is one, and it's not like I'm a real expert at this. I was an engineer for all my life until I decided to take on this lofty mantle. And it's not like, oh, I'm the CEO of Boeing, or something where it's like, I'm the CEO of a small tech startup. So what is that like? A lot of it is, I think, is trying to stay focused on the big picture, and then trying to use the people around you. Maybe use is a little mercenary of a word, but in the way that kind of drives everyone in the same direction. And I think those are the 2 skills coming into this as an engineer, where mostly I was like, okay, how do I, write the code and how do I make it maintainable and stuff like that. Those are the 2 skills that I end up using the most, or that I've had to develop, rapidly and use today. Is that helpful?
Yeah, no, it is. From a technical perspective, as an engineer, how did you get into cloud native and what were you doing before cloud native was a thing?
Yeah, so, I actually, funnily enough, most of my early kind of career and stuff was very much around AI and NLP and, machine learning and that kind of stuff long before it was cool. And I went to school. I did some research originally I thought I was going to go into academia. And then, I quickly got to the point where I was like, oh my gosh, I really like writing code and I really don't like doing research. And when I was supposed to be doing research, I'd be like, writing my little side projects and stuff. So I eventually, ended up kind of working at a bunch of startups in the Bay Area. Um, mostly in kind of NLP and machine learning roles. I worked at a company called PowerSet that was building, this whole natural language processing kind of like Wikipedia alternative and engine and stuff that got acquired by Microsoft. And then, and some other companies kind of in that space. And then I ended up working at Twitter in kind of the early days of Twitter. Well, not super early. I was there 2010, so it was about 200 people. It wasn't like the 20-person days. It was the 200-person days. Um, Starting in there as, on kind of the natural language processing, machine learning side, AI side, I guess. But then that was where I actually transitioned to infrastructure because I was like, this stuff is so hard and so hard to make a product, that really is satisfying. At least at that point in time, it was incredibly hard. And meanwhile, all this interesting stuff was happening on the infrastructure side. People were building these really interesting projects or were solving these kind of really immediate challenges for the rest of Twitter. And so I kind of got sucked into that world there. And Twitter, I would say at that point in time, I would describe it as cloud native, even though the nouns were all totally different. The verbs were kind of the same. So, we didn't have Kubernetes, we didn't have Docker, at that point in time. Didn't really have containers. Didn't have even the word microservices was like a very nascent word at that point. But we were doing all those things. We had Mesos. We were basically turning Mesos from a grad student project into a real project. So we had this idea of orchestration. We didn't have containers, but we had the JVM. So all the stuff was built in Scala or in Java on the JVM, which gave us isolation. And we had C groups, which we used. So, you kind of have a basic form of containerization. And then we built stuff. When I was there, we moved it from this, monolithic Ruby on Rails service into this massive, uh, what we would now call microservices deployment. So, like all those building blocks were there. And then when I left Twitter, that's when we started Buoyant, and that's when we kind of tried to take those same ideas and apply them to this new world that was developing in front of us around Kubernetes and Docker and like all these new things that were like kind of new technologies to us, but that were exactly the same as what we were doing, in the in Twitter.
In terms of the changes that you mentioned, whether it's from the infrastructure perspective and also moving from AI and LP into a different area. How do you stay up to date with all these things? The Kubernetes ecosystem, the cloud native ecosystem moves very, very quickly. Do you read blogs? Do you listen to podcasts? What's your strategy?
Yeah, I think my strategy is kind of informed by, my job at this point. So a lot of what I do is learn from the engineers and the people who are who are building Linkerd. So I kind of like get to absorb what they're on the bleeding edge of this stuff, and I get to absorb what they're seeing. Other than that, I don't think I do anything really special. I read r/Kubernetes on Reddit. I read r/Linkerd. I like make some incendiary comments every once in a while. Or every once in a while look at Hacker News. But yeah, mostly I just absorb it from the people that I work with day to day, who are like the experts in all this stuff. So I kind of get a cheat mode on that, I think.
That's good, but it's also building a community that solves a problem, or resorting to a community for those things. In terms of career advice, if you could go back, whether your experience at Twitter or prior to that, if you could go back and give yourself one career tip, what would that be?
The tip I would, yeah, I think the tip I would give myself is look optimize for impact. I think as an engineer, the tendency I had, and I think this is just kind of part and parcel of that, of that role, is I love building stuff, and like I kind of didn't care early on what I was building. I was just like, hey, just the act of building stuff, and like, oh, there's a cool new language or a cool new library, and look, now I get to think about things this way, and oh, I learned about continuations. Like, wow, that's a mind blowing thing. And for a long time, I kind of like just went down that path because it was gratifying, and I don't think there's anything wrong with that. But for career advice, once I started, kind of bringing my head up a little bit and looking around and saying, well, how do I actually make an impact on this company, or what's the highest leverage point? Then, career wise, things got a lot clearer to me of where I should be spending my time, and part of that I think was responsible for me, the shift that happened to me at Twitter, where I was like, you know what, the infrastructure thing is the thing that's really making a difference at this company. Let me focus on that. And like, as much as I loved, the finding, the hashtag predictor or whatever, like kind of interesting, NLP stuff I was working on, infrastructure was the thing that was really making a difference. So yeah, that's my advice. Optimize for impact.
Okay. Now, in terms of what we want to focus the conversation on today, you wrote an article called "Sidecarless eBPF Service Mesh Sparks Debate," and which is a follow up to an earlier piece that you had written about eBPF sidecars and the future of service mesh. You're one of the creators of Linkerd, which is a service mesh. For those who don't know what a service mesh is, can you just walk me through it? Why would someone need a service mesh? What is the role that it plays, the value that it adds?
Just imagine like a magical silver bullet that no matter what problem you have, it makes that problem go away. That's that's what a service mesh is. It's just, boy, that makes it sound like heroin. Yeah, well,
We're gonna say,
don't
shut up
worry,
and take my
just take
money. Come
this.
on, take
Yeah,
my money, will you?
yeah, right. Yeah, it makes all the pain go away. You'll feel great. Yeah, no, it's so uh, there's kind of two ways I like to describe it. The first, which I kind of prefer, is like, what does it do? And then the second way, which is kind of interesting if you're an engineer, is like, how does it work? So, what does it do? It is a layer that you add on top of Kubernetes that solves a bunch of stuff that Kubernetes itself doesn't solve. And there's kind of three buckets of things that it solves. It solves a bucket around security, especially around the communication, right? So can we make every connection that's happening in your cluster or between your clusters encrypted by default and authorized and authenticated? And can we have like policy on top of that that describes things in terms of services and gRPC methods or HTTP routes? Like this A is allowed to talk to /foo, but it's not allowed to talk to /var. Right, that's one set of things that it solves. It solves another set of buckets, another set of things in the bucket of reliability. So, can I fail over gracefully between clusters? Can I shift traffic between cluster A and cluster B in a way that's, transparent to the application? Can I do a progressive delivery? We talked about that very early with Argo, where I've got this new code, I want to deploy it, but I don't want to send production traffic to it like, immediately. Can I send 1%? Can I send 2%? Can I like ease into it? Oh, if things are screwed up, like roll back. Okay, if we like minimize the damage there. All of those mechanisms, load balancing, circuit breaking, retries, timeouts, all that stuff. And then the third bucket is around observability. So can I have a uniform layer of metrics for every workload that's running in my application? Things like, what is the success rate? What is the latency distribution of the requests? What's how much traffic is this thing getting? And I do that in a way, that is uniform across all my services. And most importantly, like kind of the power of the service meshes, it does this in a way that doesn't require changing application code. So you as a platform owner, as a Kubernetes, kind of like the person who's responsible for building this Kubernetes-based platform, you get control over those features without having to bug the developers or ask them to implement TLS or fight with the product managers. So that's what it does. The way it works is like maybe kind of uh, less important in some ways, but that's, I guess, the topic of this this podcast, because people like to get into the details and compare this engine versus that engine, and, you know. Um, but kind of the original way that it worked, or no, I should say the most common way that it works today, it's basically a whole lot of proxies, and kind of the reason why this makes sense today, I think, and didn't necessarily make sense 20 years or even 10 years ago, is that with something like Kubernetes and containers, it's very easy to deploy a whole lot of proxies and kind of, you treat them uniformly as a fleet. So the idea, which would have been laughable a decade ago, like, hey, I want you to deploy 10,000 proxies, now it's actually doable, right? You just like type this thing and kind of works. So the fact that we can do all these, we can deploy all these proxies gives us a lot of power. There's a lot of power over the communication that's happening there, because that's the insertion point for a lot of this functionality. Now, how do you deploy those proxies? Where are they? What kind of proxies? What language are they written in? Like, that's all the debate portion. But at the macro level, all the service meshes basically work by running these L7 proxy, layer 7 proxies that understand HTTP, HTTP2, gRPC, and can do stuff.
Really quickly, can you just touch on the, how things can change where we're talking about the data and control planes across service meshes, sorry. A little bit about, how the old sidecar model was with an extra container in order to better understand where we're at today.
Yeah, yeah. So, typically the macro level architecture for a service mesh is you have this idea of a control plane and a data plane. And, that's a very old idea from a lot of networking terminology, right? The data plane is the thing that actually handles the traffic, and the control plane is the thing that sits off to the side and allows you to interface with the data plane. You as the operator to interface with the data plane or allows the data plane to share state and things like that. So, in Kubernetes terms, control plane for any service mesh, not just Linkerd, it's basically a bunch of, regular old Kubernetes services that like run somewhere, run in a namespace or run in a cluster. And the data plane is where things get interesting because that's the actual, proxies, right? And so you mentioned the word sidecar. That's a very common approach, and that's the one that Linkerd uses today, where we add the proxy to every pod, right? And kind of like transparently injected in there. So if you have 20 pods, well, now you have 20 little proxies, and there's pros and cons, and we'll get into the gory details of that. But that set of proxies kind of collectively is your data plane. And, if those proxies are large and slow, then everything sucks. And if those proxies are fast and small, then like everything's great, you know? And so the implementation, that's like the architecture, but the implementation details make a big difference, right? Because you are adding, if you think about this in the sidecar approach, service A is talking to service B. That's kind of like our mental model. Well, what that really turns into is pod, A1 is talking to pod B7, right? And then what that really turns into is pod A1 is talking through its proxy to the destination proxy of pod B7 to the destination service. And now we're adding a couple of hops there, right? So if we're adding those hops, there's going to be a consequence, right? And we have to make sure that there's a cost to doing that, right? And we have to make sure that the value we're getting is much greater than the cost we're imposing to do that.
Related to that in terms of cost, running an extra container for each pod sounds like it could get a little bit pricey. Does cost become an issue here?
Yeah, it's interesting. Yes, there's a compute cost to running a service mesh, kind of like there is to adding any component onto your system. You're paying for CPU, you're paying for memory. Memory usually is the thing you're a little more worried about in terms of raw compute, because that kind of implies, in aggregate, that means, okay, we might have to scale up our instances, or we might need to scale up our cluster and add another node. Um, Typically, that actually hasn't been a big deal for Linkerd, because what we do in Linkerd, which is kind of unique, is we have what we call a micro proxy, which is a proxy that we wrote in a language called Rust, which is super cool and allows us to deliver these very, very fast, um, and very lightweight proxies, and also allows us to um, avoid a whole class of, this is kind of what Rust is most known for. It has memory management, kind of like compile time memory management in such a way where you avoid a whole class of CVEs and buffer overflow exploits that are kind of endemic to languages like C and C++. You avoid that by the compiler being very, very aware of how memory is managed. And so, if you're a programming languages geek, that's kind of like two basic, uh, you know, at the rough level, it's kind of two basic ways of running something. You either have something that has two basic classes of language. You either have something that has like a runtime environment that's doing management for you and keeping you safe, and has like the garbage collector and things like that. So Go is an example of that, right? Like you run your code in Go, and you're like, okay, I'm probably not going to have a big memory vulnerability in here, because the Go runtime environment is going to like manage this stuff for me, and like it'll crash the program rather than allow me to do something dangerous. Um, and then on the other side, you've got languages like C and C++ that are like, hey, you know what? Go nuts. Here's a full memory. Do whatever you want. And it turns out that basically it's impossible for a human being to really write secure C or C++ code. So you achieve security in those projects basically over decades by like finding all the bugs and issuing CVE warnings and then going and correcting them and then like waiting for the next one to crop up. So you can, you eventually get there, but it's through a whole lot of, human in the loop kind of involvement. So In fact, I think, you can look at these studies. Both, I saw one from Google and I saw one from Microsoft too, both with the same number. So basically 70% of the security bugs that they find um, in C and C++ code are because of memory management, like mistakes. So, these are the top programmers in the world, and like even they, even they can't do this. So, anyways, that's all to say. Like, so Rust is here, basically as a reaction to that, right? It's a way of saying, hey, we want to write code that's as fast as C and as C++, and we want to write it, in like a full-fledged modern language with, type inference and kind of like all those other niceties. But we also want to be able to be sure when we compile this and we give you a binary that the binary is not going to be full of used after free exploits or whatever it is, buffer overflows and things like that. So we wrote a proxy in Rust, right? So and the reason, I think one of the many reasons why Linkerd chose that approach, and you got to remember this was in 2018 when we picked this. So nowadays Rust is like the hot thing. 2018, I was like, whoa, that's a gamble, right? It's like the networking, the language had just like stabilized at 1.0. Prior to that, the language itself was still evolving, and the network library ecosystem was like, very rudimentary back then. We had to do a lot of work to, kind of core investments in some of the underlying libraries like Tokyo and Tower and H2. These are all things that, that Buoyant and that the Linkerd team invested in to build that up. But the reason why we went through all that effort is because the data plane, getting back to your original question, the data plane is the thing that the application data has to transit. And that means in the case of something like Linkerd, this is medical data, it's financial data, it's sensitive customer records, it's 911 call data. Like this is the most critical stuff you can imagine. And we wanted to be able to give our, our customers and our adopters every assurance that like, hey, this data plane, not only is it reliable, but it's also secure. And if someone breaks in and like does some naughty thing, we're not going to be the failure point there. We're not going to be the weak link in the chain. So, we use Rust, we build these micro proxies, and these proxies, because of the way we design them, and because of kind of the powers of Rust, are very, very small, very, very fast, very lightweight. And so, you run them and like everything scales up with the amount of traffic, kind of in their baseline configuration. They're like 2 megs of memory or something. It's like, kind of ridiculous how small they are. If you pour a ton of traffic into it, okay, well, we gotta consume memory to handle all that. So things will grow. But the footprint tends to be really, really, really small. And so that's usually not a concern for us. Usually the thing that it's a big cost when you're designing these big distributed systems is the latency. It's like the end to end latency. So what does a user see? Are they seeing, a tail latency, a P99 latency of like 5 seconds, or are they seeing a tail latency of, 30 milliseconds and that's because that affects user experience. It affects, whether your customers are staying around or not. And that's something that the service mesh can actually help with, oddly enough, even though you're adding these hops, you can actually optimize your tail latencies. So that's all to say, in terms of your cost question, usually it's not for Linkerd, it's usually not an issue because of the way we've designed those proxies. For other service meshes, it is because, if those proxies are big and bloated, then it's a problem, right? Then you end up consuming a lot of memory. I would say even then, though, the thing that really, the true cost, the thing that really bites you is what's the operational complexity of these things? Do I have to care and feed for these things? Do I have to hire 3 engineers to maintain these proxies because they're really complicated? Or, does this thing just work? Because in most cases, that'll dwarf your computational costs. It's like the cost of the humans who have to be involved in making this thing stay alive.
Very good point about that in the human sense. As much as we look at the technical challenges when it comes down to, like you said, the time and sifting through and rooting out errors, which and that time spent is time that can't be spent on other things. In terms of those concerns and costs, the community has sort of responded, developing different, products, projects to alleviate some of those concerns. One is being Istio with Ambient mesh, and the other is sidecarless serverless meshes like service meshes, excuse me, like Cilium cluster mesh. Starting with Ambient mesh, what is it and how can it improve on the classic, if we want to call it classic sidecar model of service meshes?
Yeah. Yeah. So, both of these things are things that we've looked at deeply in Linkerd land. And I think there's a point in the future where it may make sense for us to adopt those approaches. I don't think that a point is right there. So, I'm going to say a bunch of critical things, but I don't want that to be taken as like, oh, we're anti this or anti whatever. Every decision we're making here is a trade-off decision. Like when you come down to distributed systems, and especially the intersection of distributed systems and like having to run this in production, at a company, maybe a company that uh, you know, usually a company for whom the platform is like a means to an end, not like this amazing thing that they kind of are building for its own purpose. It's like it's there to serve the application. So in that framework, everything is a trade-off, and the trade-off that we always make in Linkerd land is what is the thing that's going to reduce the operational burden from this? So that's the lens by which I see all these things. So what Ambient does, and I think in both cases, you talked about Ambient and eBPF, they kind of both are, they're not a reaction to the complexity, I don't think. I think they're a reaction to um, the fact that sidecars are annoying in in some ways, right? Because in both cases, they're kind of their punchline is, "Hey, and guess what? Now you don't have to have sidecars." Now, how do you get there, right? And it's like that's where you find out the cost of this approach. So in Ambient, kind of at the rough level, you don't have sidecar containers. Instead, you have some like connective tissues, a tunnel or something that you run in the names in the namespace, and then those talk to some proxies that are running somewhere else on the cluster. So you get a bunch of proxies that are running outside of the pod, and you have like a tunnel thing, and the pods use a tunnel to talk to the proxy, and the proxy does some stuff. But the reason why that's interesting, and the reason why sidecars, I said originally sidecars are annoying, is because sidecars have some implications when you run them. There's like the cost thing, which we talked about, which in Linkerd's case, is not really a big deal. I think the bigger one is um, in order to upgrade the proxy, in order to like update it with the newest version, you have to restart the pod, right? Because pods in Kubernetes are immutable. And I think there's very good reasons for that to be the case. But what that means is, okay, now we have to kind of do two things, right? Or like we're keeping our applications up to date. And also, if we ever want to upgrade our service mesh, well, now we have to update the control plane, and now we have to update the data plane. And that's kind of annoying. There's some other kind of little nuisances, for complicated reasons. We run the proxy as a first container, um, which means that kubectl logs, like if you just ask it for the logs, the proxy logs, that's usually you want your application. There's little sources of friction like that. And I also think, honestly, I think it's kind of like a psychological thing, which is like, I don't want to see the proxy. The fact that I have to see it is like, means that, it's annoying. Now, who sees it, right? Like, do the developers see it? No. The platform team sees it. Can't the networking just be invisible to me, right? So I think there's a little bit of that, but that's all to say, both Ambient and the eBPF stuff, which are really not orthogonal, as we'll get into, those are all they're all kind of a reaction to like, I don't want to see the sidecars, I don't want the sidecars to be there. And in the case of something like Istio and most service meshes which are built on Envoy, Envoy is complicated, and Envoy is memory hungry, and Envoy is something that you have to care and feed for. Like you're tuning that thing, based on the specifics of the traffic, and I think a lot of our investment early on kind of like got us into a better spot. So I, I, I kind of like, I bristle a little at being painted with the same brush because I'm like, a lot of the problems that you guys have with sidecars, Linkerd doesn't have. It's, those are like Envoy problems. They're not, sidecar problems per se. But this is the cloud native world doing, you got to get some marketing in there and paint everything with a brush and like, write the blog post that says we're killing sidecars, death to sidecars. All right, sure. I guess, now I have to write the article. It's like, well, hold on, let's make an informed engineering based consideration. And like, that's much less exciting to read, right? I don't want to read the informed analysis. I want to read the like death to the enemy kind of blog post. Okay, so for Ambient, you get rid of sidecars because you're running the proxy now somewhere else, and you have these tunnel components, and that's nice because you can kind of maintain the the proxies separately. So like you need to upgrade them. Okay, you don't have to reboot your apps. Now, I would argue that if you're deploying this stuff in Kubernetes anyways, like the whole model of Kubernetes is your pods should basically be rebootable at any point. Like, Kubernetes can reschedule these things whenever it wants. There's no guarantee that a pod is going to live for any particular period of time or whatever. Like, this is like the whole point of Kubernetes is you build your application as a distributed system, and you should be able to scale it out and scale it down and shuffle around between nodes. But there's legacy applications, just things written in some way where it's like annoying to reboot them. Okay, I get it, sure. And in those cases, like the sidecar approach is annoying. There's other warts too. I think, jobs for a long time, cron jobs and other types of jobs were annoying to have sidecar proxies on because basically there was no mechanism in Kubernetes to tell the proxy that like, hey, the job's done. So like you can shut down now. Like there's literally no Kubernetes way to know that. So you had to go through these hoops where you were like, okay, I'm running this job and now I have to have it signal to its proxy that like, hey, I'm done. And, that kind of violates the premise of the service mesh in the first place, which is like, hey, we want these things to be decoupled, right? We don't want the developers to have to know about the sidecar and have to do some extra code. Well, you can do it in the Docker config. It's just like, it was just annoying. Those warts are being addressed. So there's a Kubernetes, very famous Kubernetes KEP, Kubernetes enhancement proposal called the sidecar container. That was first opened in 2019. I wrote a blog post about that. I'm actually giving a talk about this at KubeCon in Paris. First opened in 2019, and that's like finally, 4 years later, just last year, made it to alpha in 1.28, and will be in beta in Kubernetes 1.29, where you can mark your proxy as a sidecar container, and then there's a bunch of nice consequences to that. One of them being, hey, your jobs can actually terminate, like the proxy once they know that they're done. So there's little warts like that that are slowly being ironed out. I guess I should say wrinkles. You don't iron warts. They're little wrinkles that are
removed, sorted out,
right.
dealt with,
Surgically removed. Yeah, yeah.
The main thing is that there's progress. Yeah.
Yeah, that's right. So, my analysis of Ambient, so we did a pretty deep dive right now. My analysis of Ambient is like it adds more complexity than it's worth for Linkerd, because now you have these extra components. You got a tunnel component. Now you've got the things running in, the proxies running over here. It's like, I understand the motivation. We haven't seen the pain in Linkerd that I think Istio has seen because of their choices. So the trade-off is not there for us. I don't think it's a bad approach, in contrast to the eBPF one, which I think actually is bad. I think Ambient is fine. It's just we haven't seen that pain. So like, why bother? And the final point I'll make on this is what's really nice about the sidecar approach. What's really, really nice is that the operational boundary and the security boundary are very clear, right? They are the pod. The pod itself makes its own decisions about security, makes its own decisions about, operations, and you can treat that thing as a unit. And that's kind of like the Kubernetes way, right? And so, even when you're talking about something like zero trust, we've got the zero trust philosophy, which has like, kind of has all these aphorisms and sayings and whatever. But like one of them is you got to have enforcement of these things. It's got to be at the most granular level possible, right? We don't have our firewall anymore and then treat everything inside the firewall as, as all trusted, right? Every security decision has to be made every time at every level. And so when you have a sidecar in the pod acting as its security boundary, you get that, right? Like no request can come in here without the sidecar itself validating. In the case of Linkerd, validating, is this a valid TLS request? Do you have a valid, client ID, not IP address, because you can't trust the network, but like a cryptographic, like service identity. Do I trust that identity? Can I have like a TLS cryptographic chain of trust where I believe that identity? And then, are you allowed to talk to me? Are you allowed to call this particular method? All that stuff can happen in the pod at the most granular level possible in Kubernetes with sidecars. And as soon as you move away from that, where, the proxy's over here and the TLS certificate's over there, then you start losing that very clear model. So that's kind of the security argument. There's an operational argument too that we can get into maybe when we get more into the eBPF stuff.
Yeah, good. And speaking of which, that's the next point I want to touch on. It's got a lot of attention the past few years, through not just Cilium Service Mesh, but we're hearing a lot about EPF in many different areas. Sometimes talking about networking, sometimes talking about observability, sometimes talking from a security perspective. When you're asked about eBPF, how do you define it?
Well, I think defining it is pretty easy. Like it is a kernel, technology that allows you to run certain types of code inside the kernel, right? And like that's interesting for I think two reasons. One, because inside the kernel you can be very very fast. If you're processing network packets, you don't have to bounce back and forth between kernel space and user space, right? And it's also interesting because the kernel has access to like everything. So this has to be done in a really really secure way. So kind of like traditionally, right, you wouldn't be allowed to do that. You as a user space program would have to talk to the kernel and say, hey, can you please give me the data for packet 1 2 3 4, and the kernel would say, okay, here you go, right? And you have this like the syscall boundary is what it's called, system call. And that's expensive if you're doing that a billion times, a minute or whatever. Modern network hardware can get really really fast. You get a lot of packets in there. And so that part is expensive. So, hey, maybe we can just do that analysis in the kernel. But if you're doing it in the kernel, well, now it's like you let someone into the inner sanctum. Like anyone here, they're in the Oval Office standing next to the president, and they can do whatever they want. So the way eBPF kind of worked around that is it said, okay, we're gonna have this bytecode compiler, and we're gonna have all these like kind of checks in here that only allow you will only run things under certain conditions. And it's very, very restrictive. So the set of things that you can actually run there, it's like you can't have any unbounded loops. The bytecode verifier, which is what's called, has to be able to explore every possible outcome, and make sure you're not doing anything naughty. You can't, your size, your number of instructions is like limited to a certain size. uh, it even checks. This is like the crazy part of me. It even checks that the bytecode is GPL licensed by like looking at the first couple bytes of the bytecode and looking for the strings GPL, or something crazy like that. There's like all these things that they put in there, right, in the name of security. And so the result is, okay, we've got this really cool mechanism that actually unlocks things we've never been able to do before, but it's also very restrictive. So you have to be really clear, in what is eBPF capable of and what is it not capable of. And I think that's where the marketing really tries to blur those lines. Hey, eBPF is cool, brand new solution. It allows us to, throw away sidecars. And like that's not really the case, right? There's a choice to use eBPF or not. And then there's a separate choice, orthogonal choice, independent choice that says, are we deploying things as sidecars, or are we deploying these proxies in some other way? Are we deploying as a daemon set, which is what Cilium does?
Okay, so as you said, there seems to be perhaps some confusion about where that there are limits that are there that maybe aren't evident at first. If eBPF is limited, does that also mean that all service message meshes? I don't know. I'm stumbling on that. If eBPF is limited, does that mean that also that all service meshes are that use eBPF are subject to those limitations?
Yeah, no, no, not at all. And this is like where there's like a little bit of smoke and mirrors. Like the eBPF service mesh, the heavy lifting there is done by an Envoy proxy, anyways, right? So, in order to get that functionality, so eBPF, for example, one thing, so just restricted to the network space, and there's a whole bunch of applications. I could say there's security applications, there's like performance monitoring applications for eBPF. I think that's actually the most interesting area for eBPF is instrumenting applications, because since you're sitting in the kernel, you can compute usage, of CPU and function calls and stuff like that in like a very very direct way. So I'm just talking about the network kind of usage. eBPF, one of the things that's hard, bordering on impossible, but not quite impossible to do, is to maintain significant state. So you parsing a bunch of TCP packets and like counting, how many come through with this IP address and this port combination. That's very easy, right? Like that's finite, data structure. You parsing HTTP2 is basically impossible. It's basically impossible in eBPF. Now it's not actually impossible. Like you can have these. I would describe them as academic exercises where you're like, okay, we're going to split the way we're going to do HTTP2 parsing is we're going to split it out so that like we're going to re-enter eBPF land, and then we're going to like maintain this data structure. We're going to do it over here, and then we're going to re-enter. And we're going to keep doing that. But you have to go through contortions where at the end of it, you're like, wow, I guess you technically did parse a small amount of HTTP2, but like it's not what anyone would normally do. So in practice, what they do is use eBPF for the layer 4 stuff, right? What are the TCP, how many TCP packets are passing between A and B? We can do that really well. And there's some other cool stuff you can do there too. Um, but then anything that involves like what we call layer 7 stuff, right? HTTP2 parsing, like I want this request and I want to look at I want to look at the header, and it's encrypted via HPAC or whatever, and then I want to make a routing decision based on, or I want to do I want to do a TLS handshake or anything like that. You kind of have to do outside of eBPF. So in the case of something like Cilia Mesh, we'll envoy proxy, and they deploy that proxy as a daemon set. And that's the part of it that I don't like, because that's the part of it that actually makes it sidecar free. But that's the part of it that actually makes it worse, right? So you could use eBPF with sidecars, and then I think you'd actually have something quite nice. And this is kind of the direction, we're looking at in Linkerd is like, hey, let's keep sidecars because they've got a clear operational boundary, clear security boundary. And let's add eBPF because it actually can help with some things. So for example, sometimes you're asking Linkerd just to proxy a TCP connection from A to B, right? So, hey, this is some obscure protocol, or this is some, a protocol that we invented, or this is a client initiated TLS thing or something. We're like, I don't want you to interpret this thing, Linkerd. I don't want you to look at requests and responses and do load balancing, whatever. I just want you to proxy. In that case, there's no real reason for Linkerd to do anything other than just like hand it off to the kernel and say, hey, send these bytes from here to there. Right. So that is something that eBPF would be able to help us with. And that would speed up that kind of raw TCP proxying case, I think, quite dramatically, possibly for Linkerd. But for anything else, for anything that is kind of like interesting from the service mesh perspective, and by interesting, I mean, load balancing gRPC requests based on the latency of the endpoints. So you got 30 different endpoints, which one's the fastest? Okay, send a request to that. Or initiating a TLS handshake and doing like, L7 policy authorization on top of that. You basically need a proxy running a user space. And so then your choice is, okay, eBPF doesn't help me with that, right? I have to run a proxy user space. Do I want to run that proxy as a sidecar, or do I want to run it as a daemon set? And if you run it as a daemon set, the problem is, yes, you have no sidecars, but the problem is now, if you're doing TLS, all those TLS certificates are being mixed in memory of that sidecar, or in the memory of that daemon set proxy. Well, that's crappy for security reasons, because there's um, oh gosh, I'm forgetting the name. There's like a classic security problem. It's like the deputy, the unauthorized deputy. Okay, blanking on the name. But you've basically deputized that thing to act on your behalf, and it could go rogue. Like you've got no idea. It can't. It's got all the TLS certificates for all the pods. So like, what's the point of doing TLS? You know, uh, you know, uh, if they're all being mixed together and this is acting as your representative. And you've got a much crappier operational model, because if that thing goes down, then like some random set of pods that were scheduled on that machine now suddenly are unable to communicate. Or if you're rebooting that thing, well, now you've got a random set of random pods from random applications that Kubernetes has decided to schedule on that machine, who are now unavailable. And the reason why I'm so familiar with that is because Linkerd 1.x actually ran as a daemon set. So we knew this model inside and out. We were like, great, why bother with sidecars? Let's do daemon sets. And then, every single user was like, oh, this sucks. Every time we reboot this thing, it's like, it's really hard to figure out what's going on because random pods go down. And, how do we do MTLS in a way that we feel safe with? So, I think if you unwind from there, basically after what our analysis, and we dug pretty deep into this, what our analysis kind of led us to is like, eBPF is cool. I think there's ways we could use it in Linkerd, but it doesn't change anything about the trade-offs between running things as a sidecar, running things as a daemon set, or even the ambient, like running them somewhere else, and having like a tunnel component. Like that trade-off is totally independent of whether you're using eBPF or not. And the thing that kind of irks me is like it gets smeared together in marketing land. Hey, we've used eBPF, this amazing technology to kill sidecars. Well, no, those are two independent choices that you've chosen to kind of present as one. But if you take it from the engineering perspective, kind of independent.
And like you said, there is
Apologies for my very long, very
no,
deep
not at
rabbit
all,
hole.
not at all. It's like you said, whether it's, but we see this all the time, and that's often why as well too. In the very beginning, asking, why one and not the other? What are the trade offs? And and if we're in the Kubernetes world, we go for folks that were in the container orchestration wars, Kubernetes versus Mesos. Some people to this day will still say that Mesos was a better technology. Kubernetes had other factors behind it that led to that, but that's another podcast for another day. The point is, there's a lot of experimentation, innovation in this field. A lot of people working really hard in different communities. If we dig deep enough, I'm sure we could find a romantic angle, and Netflix would want to produce a series about it. But what do you
Oh,
expect?
oh.
If thinking seriously, what do you expect to happen in the next, let's say, couple of years regarding this? Have we reached the peak in terms of the conflict or doubts around service meshes and sidecars? Do you think there will be some kind of a peace treaty? Can we expect new factions? What do you anticipate in the coming months and years?
Yeah, well, I love the fact that this world is so open to experimentation and so open to trying new things and is so kind of aggressive about pursuing new angles. I think that's great, and I think the only aspect of it that I don't like is when the marketing is used as a way to kind of like push one solution over another versus trying to take an engineering uh, analysis and especially I think for those of us who are so focused on the operational benefits for or the operational aspects implications for our customers, that's just it's not a very sexy exciting argument to make. So I'm like, how do I gussy this up, yeah. So I think that's all great, and yeah, where is this all going? I think the value prop for the service mesh is pretty clear in people's minds by now. Early on it was like, oh, lots of hype. What does this thing mean? I want to learn about it, and now it's like, okay, whatever. I know I need a service mesh. I don't really care, pick one to move on. And, in some ways that's nice. Right. In some ways it's like, all right, we're at a much more mature state now. And I'm not telling people, well, I guess I am occasionally telling people, here's what a service mesh is and here's why you should care. But that's like not 100% of my conversations all the time. And I think they're kind of converging in terms of functionality too. Like a lot of the features are clear now. Okay, you need MTLS, great. You need load balancing and circuit breaking. Okay, great. You need mesh expansion. So you need to be able to pull in non-Kubernetes objects. That's actually the big announcement we're making in about well, it'll be mid-February whenever anyone listens to this for
Whether it's
Linkerd
a past or the
2.15.
future, it's exciting. Yeah, check it out.
Yeah. Yeah. So yeah, come check out Linkerd 2.15. Like we've added the ability, and this is like a huge step for the project, to run the data plane outside of Kubernetes. And so you get the same TLS communication to and from your VM workloads as we've been providing for your pods. So profound step forward for the project. But like these things are all kind of, moving in the same direction. And in fact, you even see things like the gateway API, which is an API built into Kubernetes itself that is slowly, and we're part of this, is slowly converging to consume not only how do I configure ingress, but how do I configure service mesh, right? So can I use the same configuration primitives to talk about traffic, not just as it comes into the cluster, but as it transits the cluster, and maybe even as it egresses the cluster? I think the answer is yes. We're not quite there today in, the beginning of 2024, but we're not that far away from it. So you even see these standards evolving to kind of consume. So, I think that's great. Like that's a sign of a healthy technology. I think we'll continue to refine things. I think that the industry as a whole will continue to refine, some of the little bits and pieces of, okay, can we use eBPF in these situations? Does Ambient give us advantages in those situations? But like kind of the value prop is the same for all those things. So what I'm excited about, kind of the next step is, well, how do we apply this to, kind of an organization as a whole? The customers that we see, that are like the most forward thinking customers, our foot in the door is Kubernetes. They're like, okay, we've got this new Kubernetes thing. Sure, like let's make it secure and compliant and reliable. And then they're like, okay, well, how do we expand this to the rest of our organization, right? And that's the part that's really interesting to me because I feel like what the service mesh kind of represents is a new level of networking. It's a new abstraction for networking where kind of at the core, you're not talking about IP addresses and like, can I establish a TCP connection and safely pass packets from, reliably pass packets from this IP address and port to that IP address and port. Instead, you're talking about a network where kind of the primitive is I'm service A, represented as this actual, set of instances juggling across machines, IP addresses change all the time, blah, blah, blah. And your service B, can I establish a secure, reliable connection to you? And that's like the baseline primitive. It's not just like establish a TCP connection. It's like I need a secure, reliable connection, and then I can start building stuff on top of that. So that's the part that gets me excited. And that's kind of the direction we're heading with Linkerd is, the technology is always fun to talk about and it's fun to argue about, but like kind of at the end of the day, you want this stuff to become plumbing. You want it to become like, things that hides in the walls and, you don't really have to think about it. You're like using the sink or whatever. I don't know. So that's not a very
Yeah,
exciting
just
analogy,
no,
but
just
you get my
normal
point.
functional. Yeah, it's like what the Kelsey Hightower quote that eventually Kubernetes will just kind of disappear in the background, will become boring, things of that nature, and I think a hell of a lot of work has to go into it for that to happen. Like you said, also that it doesn't always have to be an emotionally charged conversation saying, look, we're trying to make people's lives easier, and hopefully this will become something as routine, like you said, is using the kitchen sink. Um, Shifting away from the professional and more to the personal side now, we found out that you have an interesting tattoo. Is it of Linkerd or what is it?
Yeah. Yeah, I did tweet. I did tweet this picture. So I'm gonna disappoint you, which is that was a temporary tattoo. It's not a real tattoo. So as part of our this was at KubeCon, I think a year ago. One of the bits of swag we had to give out were temporary tattoos. Everyone gives out stickers and stuff, and I was like, well, we can be a little cooler than that. So and it's a temporary tattoo of Linky the lobster. Um, who's a representative of Linkerd. When Linkerd graduated, so CNCF has like these tiers of project and graduation. It's like the top tier. Okay, project's really mature. So Linkerd, of course, was a first service mesh to graduate, a testament to the maturity of this beautiful project. But when they graduated, they made us pick a mascot. And most of the mascots you've seen these. It's like, oh, you got the cute little gopher for Go, and you've got a cuddly, I don't know, something else. And we were like, well, what's the what's the least cuddly object you could think of? What's the least cuddly critter? And it was a lobster. So we're like, all right, Linky's got a blue lobster, which in some ways is like Linkerdy's, kind of position in the CNCF universe. We're kind of like the ugly, rare thing that people are like, I guess the lobster's here again. I'm gonna go over here. At least it feels that way sometimes. So yeah, we got Linky the lobster. That was a tattoo, and I think in that case, Linky the lobster was actually crushing some sailboats in his hands, which of course is the logo. So we put in a little, a little Easter egg in there. Linky the lobster, a giant lobster rising out of the sea, crushing some sailboats, and that was a temporary tattoo. If you were there at KubeCon, well, I don't know where that was. Amsterdam maybe.
Okay.
Yeah, you could get your temporary tattoo.
All right. So you don't have any tattoos, not as of yet.
Not yet, but let's see how Linkerd does. There's
Okay.
always
Okay.
opportunity.
All right. We'll look forward to hearing more about that. What's next for you? You're obviously very active mind. Yeah. Apart from this, is there anything else that you're working on? Any side projects?
For me personally, gosh, I'm
Yeah.
devoting all of my life energies to Linkerd and to Buoyant. uh,
Sounds like it.
I am as a I'm a dad. I've got kids now. They're learning the piano. I'm like, okay, I'm going to start learning the piano too as an adult learner. I can tell you, it is humbling how fast kids will learn and how slow you are. So it's nice to be in that kind of role sometimes where, I take lessons from a teacher who's probably a third my age, who's like just phenomenal. And I'm like, so much of my day, I'm like, acting as the authority figure on something. And now I'm like, okay, I'm like the shitty student here. I'm like, you know, So it's nice to have that kind of little reminder to be humble, which maybe I need a little more than most people do. So yeah, that's really it.
That's good
Raising
balance. I
kids
mean,
and yeah.
that's I think that's really good balance. I think it's a nice reminder for a lot of people is like, it's okay to do something that you're not super good at. It's not a big deal. And
And it's hard, as a kid, what you realize is as a kid, you're used to doing that all the time. Like you're never expected to be particularly good because you're like,
it's
hey,
all
I'm a kid.
good.
As an
Exactly. It's no
adult,
judgment.
you know,
Yeah.
yeah,
No, but as
you
an
go up
adult,
there
but
and
on top of it, CEO, I think the it can be something to struggle with. I actually, because
I mean, I've
as
given Linkerd talks. Sorry, I was going to say I've given Linkerd talks to like hundreds of people. So I've given Linkerd talks to hundreds of people and felt very confident. Never felt a moment of panic. And then I've, tried to do a rehearsal in front of like a piano recital in front of like 20 people, and it's terrifying. It's just it's complete opposite. So yeah, it's a
so
good
at next
reminder.
KubeCon, would you play piano if I bring a keyboard?
Hell no, that's a zero way.
I tried. I had to try. I had to try.
Yeah.
Okay, well, it's all good. If people want to get in touch with you, what's the best way to do it?
Yeah, you can send me an email. That's easy. William@buoyant.io. Just make sure you spell it the right way. Look it up in the dictionary if you have to. It's Buoyant. It's a real English word, but it's weird because the U is before the O. Or I'm on the Linkerd Slack, so you can always jump in there. It's like slack.linkerd.io. I used to be really active on Twitter. I'm kind of like not so much anymore, but I guess you could send me a DM and I might see it. I'm just WM on Twitter. But yeah, come talk to me. I'd love to, tell you about Linkerd, or maybe more realistically, I'd love to hear about what kind of challenges you're trying to face and see if there's something you can do together.
That sounds great. William, thank you very much for your time today. Really generous with your knowledge, how you share things, the perspective that you provide. Really appreciate it. Looking forward to seeing you in KubeCon in a month or so.
Thanks, Park. It's great to be here.
Pleasure.